Welcome back to Applied Algebra. We are moving on in Chapter 7 with Section 3. We're moving into direct variation. In the next lesson, we'll do inverse variation, which is slightly different. So with direct variation, the idea is that things change proportionally or the same. As one item increases, another item increases. Or if something goes down, the other item that it is the same as goes down. So their ratios are constant. When dealing with direct variation, you will see things written in terms of a proportion. Because as the variables are changing in one direction, they're going to change the same in the other direction. Some examples of that are with mechanical advantage, and that's the idea of a hydraulic system, where if the more power I give it, the more things I can lift. And a hydraulic system just helps me do that. It can also be found in things like the longer I drive, the time goes right, then the farther I drive. So we're going to use the formula for a hydraulic press to find the mechanical advantage given that FL, now F is the force of the large object, and that's 5,000 pounds, and FS is the force of the small object, and that is 300 pounds. So since both of these just have to do with force, I'm just going to do the MA equals FL over FS. So the FL is 5,000, the FS is 300. I'm just going to reduce that. My zeros can just cancel, so I'm left with 50 over 3. So mechanical advantage is 50 over 3. If I want to think about what that would mean as more of a whole number, that's 16 2/3. So it's going to increase what I can do by 16 2/3. So if I can only lift 2 pounds, it is increasing it so I could now lift a little over 32 pounds. So it's changing it by a little over 16, almost 17 times. So this one, again, gives me FL, but now I'm looking for FS, and they give us the mechanical advantage. So this MA first part will be 60 over 1. My FL is 3,500, and I'm looking for FS. So I end up with this proportion that I have to solve. So I solve it just like I have been. So 60 FS would equal 1 times 3,500, which is 3,500. Divide that by 60. And the force from my small object is 58 1/3 pounds. So my larger object doing 3,500 pounds is my smaller object doing 58.3 pounds. Because it's saying it's making whatever my smaller is, it's increasing it by 60 to get my larger one. This one is dealing with things in terms of radius, and that happens a lot with like pulleys and stuff, things that have a round object that you're working with. So if you look up above, when you're dealing with the radius, you have to make sure you square them for the mechanical advantage. So my mechanical advantage here is R for the largest one squared over R for the smaller one squared. So it's going to be 27 squared divided by 3 squared. You do have to make sure you square them before you reduce them. Resist the urge to divide first. So then 729 divided by 9. So it's giving me an advantage of 81 times. So this last one here gives us examples where they're using all the LFLs, FSs, and Rs all in one fell swoop. So on the top it does have that all put together, so I'm just going to rewrite it down here so I don't have to scroll back and forth. So the FL is what we're looking for. FS is 25. My larger radius is 8. Remember, we always square our radii. And the bottom one is 2. So I'm going to do all the math together. 2 squared is 4, so that gives me 4FL. And I'm going to go ahead and do 25 times 8 squared. So that's 25 times 64, so I get 1600. So I'm going to divide by my 4. 1600 divided by 4 is 400. So the larger force is 400 pounds compared to the smaller one only being 25. Okay, so these are examples of how it's used in hydraulic presses. There's another video I will post and it shows you some examples in other forms. Have a good day.